Welcome everyone, and thanks for being with us for today's webinar, Remove Barriers to Cloud Computing with HCI and Hybrid Cloud Mobility, brought to you by Scale Computing. A reminder that this webinar is being recorded. You'll receive an email from us within a couple of days with the link to check out the recording on demand. Also, there's a Q&A box on your screen. When you submit a question, it'll disappear from your box and queue up on our side. But don't worry, we have it and we'll get to those questions at the end. If we don't get to your question, remember we'll be able to follow up with you after the event. There's also a live chat, so jump in and have a conversation with your fellow IT pros. There's also some information in the handout section, so take a look at that so you can get some more information. But let's get started. Our presenter today is Mike Lyon, Service Delivery Manager at Scale Computing. So Mike, I'll hand it to you to get started.
All right, thanks David. Thanks everyone for either sacrificing your lunch hour or taking time out of your morning to join us today. I promise not to bore you to death with presentations. I really want to tell a story about hyperconvergence, cloud computing, hybrid cloud, and why we're running into some obstacles in getting there and how we can solve some of those problems and address those challenges to really get a true hybrid cloud in place that's sustainable. Just to give a little bit of a background on Scale Computing, the word hyperconverge, for what it's worth, actually came from us. We were first to market in 2012, launching HC3, and prior to that we had built and developed scale-out storage appliances. So we've been in the marketplace for quite a while. We were the first to market, leveraging KVM as a hypervisor, and we've really been leaders in the space for quite some time. And really the core part of our product that we're proud of is making it both incredibly simple to manage and use, as well as being very highly available and redundant. Simplicity and reliability are two tenets that everyone looks to the cloud for. But in reality, you can have some of those same simplicity and reliable, or simple and reliable infrastructure components on your own premises, managing yourself. But HC3 is a hyperconverged product, and it really is designed to address the needs of the small to mid-market enterprise. 1 to 5 people in your IT shop where you're supporting 100+ users. You need something that's easier to manage, where you can go home and not have to worry about being tied to your phone and having that Velcro to you everywhere you go, waiting for the next alert. And hyperconvergence really is the idea of trying to simplify and get rid of the complexity of the layers that we currently have today in the inverted pyramid of doom, where we're managing physical hosts, we're managing our SAN or server components separately with different orchestrations and different management interfaces, different support contracts. That's really what the goal of hyperconvergence is to simplify that, where you really have your hypervisor and your storage merged together in one stack. And technically the definition would be the integration of the compute, storage, and virtualization layers of infrastructure into a single solution architecture. But in reality, it's about abstracting all those layers of the servers, the storage, the virtualization, all the compute resources you need, and managing them for you so that you're presented with a single pane of glass to manage your entire infrastructure. Again, you're not managing those discrete components separately. You're not dealing with your servers, physical hosts, the licensing on top of that for your hypervisor software. It's just all in one appliance form factor. Now that definition is probably a little easier to nail down and define. Cloud computing, however, depending on who you ask, you're going to get a different answer. But I like the simplest approach of really just saying the delivery of computing services over the internet, because those services can be anything from a full VM, you're a consumer, and I'm just using that as an example. I just want to procure a sandbox to test VMs, all the way down to individual discrete services, AD or SQL or log analytics. All the different providers that are out there have different offerings, and even something like Office 365, offshoring your Exchange and Office components to the cloud. I mean, that's an example of a computing service that's delivered over the internet. So it doesn't just have to be infrastructure-esque components. When we look at the cloud and we look at the appeal to it, we wanted it to be simple. We wanted to have scalable resources and predictable pricing, specifically to the point that today, if you lay down a significant capital investment in your IT infrastructure that's supposed to last 5 to 7 years, obviously within 5 to 7 years, technology is going to change, and you're probably going to be pivoting on some point into your infrastructure. Maybe it's your CRM or your other application. Things are going to change, and that huge investment in your infrastructure is suddenly going to require a forklift or a significant upgrade. With a cloud-type model or an OpEx model, when you have a recurring cost, it gives you the ability to be a little bit more predictable and then also agile. So when you do have needs change, the applications you're supporting change, you can be fluid and make those changes along with it without having to rip and replace the entire stack that you've got in place. And that's why cloud adoption has really become very prominent and very important, and why we've begun chasing that dream, I guess, to move everything to the cloud. What's interesting and ironic is 15 years ago, these were the same reasons we all wanted to virtualize. Right? We didn't want to be buying another DL380 for just an app. We didn't want to be doing one server per app, so we virtualized. We wanted to make our lives easier. We wanted to simplify our lives. We wanted to gain some more control over forecasting our costs and giving us more efficiency and resources, since we could create hundreds of VMs, whereas before maybe 2 or 3 per server, and giving us that agility. Right? We wanted to virtualize. That made sense. But some of the reasons and goals and benefits of virtualization never quite materialized like we wanted them to, specifically in the management ease, and then also being able to affordably provide a reliable, fault-tolerant infrastructure without having to double down on everything you invested in. And so those really translate into the same appeal of what's important for the cloud. We want it to be easy. We want it to be affordable. That's why we virtualize. And now even more, going beyond the infrastructure services, it's really everything as a service these days. Platforms and applications, on a larger scale, something like Salesforce.com, and even they've got different silos from within Salesforce where you can consume marketing services, you can consume lead generation services, or even something like email, right? We're all moving to Office 365. No one wants to run and maintain an Exchange server anymore. No one wants to run and maintain any NCA for that matter. And it's the same thing for storage. We can create huge lakes of cold storage, archive storage that we don't have to worry about keeping on premise, but we still need to keep records of. The cloud seems like a perfect place to just keep those safe, secure, especially if it's, again, cold storage that doesn't need to be retrieved frequently. And then containerize. So Docker, Kubernetes, it's similar to delivering individual discrete components as a service, but you can get a MySQL container instance or a DHCP server instance. With Microsoft, Azure is doing even, they've taken the composition of a basic Windows server with the different roles, DHCP, DNS, et cetera, and they're even breaking those out into the atomic units and delivering those as a service. So you can have AD as a service, DHCP, DNS, all those things are really broken down into their atomic functions and can be offered as a service. And in a way, it gives us the ability to not have to manage those day-to-day operational services and all the overhead and minutia that comes along with it. Database, BigQuery, SQL, you can have your entire database infrastructure hosted in cloud, as well as the expanding growth of IoT. So every Internet of Things vendor is looking to have some sort of cloud presence, whether that's a cloud-based controller that you're using to manage it, or that's where they're storing the data. Your security cameras at home, your dash cam if it's uploading, those are all examples of IoT and also storage as well. So it's really that XaaS model. Everyone wants to say that just because it's hot and it's appealing right now, but it's an extension of cloud computing, and it really is part of what a hybrid cloud strategy could potentially look like. So again, who wants to do these things that we used to spend hours, years of our lives shaved off from the stress of having to manage mail and keep it up, and managing and providing somewhat mission-critical services for our end users, file shares, all the way down to VMs or authentication services, data analytics. These are all things that no one wants to take these on because the overhead from the infrastructure, the overhead from your time is not worth it compared to what you could do when you can have an AD service for you, right? I don't have to stand up and configure an entire DS infrastructure. And data analytics is another big part of that. As we start to look at everyone's getting big into logging and all the log analytics, taking advantage of the cloud, that's a perfect place to do it, right? Endless amounts of storage, endless amounts of compute resources that you don't have to pay for and manage. So what happens today, and why are there so many challenges, and what are these realities that we're running into looking like? Part of it is the uptime claims are a little bit out of reach and a little bit out of reality. Last year when Amazon had their outage, it was a funny story. During an S3 conference, they were talking about how S3 had 11 nines of availability, which meant that it would only go down once every 10 million years. And the guys doing the presentation never got to finish it because S3 went offline, right? So now they've got, they cannot take another outage, I think, for another 50 million years to maintain that 11.9. But the moral of that story is they were a little bit aggressive in promoting their availability, when in fact the reality is some of those services and their reliability aren't going to match up with what you may actually need to have access to as far as your reliability. How do you get access to and recover from disaster scenarios, whether it's a full-on hurricane or storm, or it's something more likely like a data corruption issue or some sort of stupid user trick that has caused you to get involved and have to try and resuscitate some data? How do you get a DR plan in place to the cloud? And then even more so, what's the right way to diversify your workloads between ground and cloud? I mean, common sense, sure, it's easy to say emails should go up there, but when you're maybe building out a sandbox or looking to onboard a new application with a vendor, it seems like a great sandbox place, but are you going to wind up spending a significant amount of money running multiple copies and multiple compute instances, when in fact you probably could get by with 2 or 3 VMs on your ground hardware, on your on-premises. But there's not always a clear guideline on how to diversify your workloads and optimize them so that your optimal cloud workloads that can run in those types of situations and run on those resources are going to be better off in the cloud, and which ones are going to be better off tangible and in your ground cluster. There aren't the tools or data or optics to say here's where this should go and here's where that should go. As much as we can say we have access to high-speed internet, and we really do, it's not quite as ubiquitous and reliable as we still need it to be. And specifically, getting a redundant connection can be a cost challenge for many people, many businesses. It's not hard to get high-speed internet drop, but if you're going to be having cloud services that your business relies on, you have to have a second internet feed. Otherwise, that's a huge exposure, and that risk of having that primary connection goes down, it can easily be offset with a second connection. But you may not be in an area where either that's a viable option or it's just simply not affordable. And then there's the actual issue of data movement. So this is going to depend on how fast of a link can you get, but how much does it cost to get that data back out? In almost every cloud instance, the providers have a honeypot / fly trap, as I say, where it's free to bring everything in, but then you can't get it out without paying. And that's just the standard paradigm across all the cloud providers. But with that being said, looking at above at some of the questions we were asking before, how do we handle disaster scenarios? How do we maintain the workload diversity and also have the ability to move those workloads between your ground resources and cloud resources easily and, again, affordably without having to continually if you're constantly moving workloads back and forth, you're going to be constantly spending money on the egress bandwidth so to get the data back out. The cloud providers have done a really great job of making it incredibly easy to move everything you want to up there. But getting it back out is really where some of the challenges. And they don't want it, right? They don't want you to move anything out. They want you to be locked in and homogenized with one specific vendor. And that's another challenge in general with cloud is that there's not a specifically unified set of APIs or protocols or any way to unify the interfaces and to simply unify the management of, if I've got AWS resources, I've got S3, I've got Google Compute resources, how do you manage those effectively? It's difficult, and there's not a single pane of glass that can handle all those for you. And then the networking piece is really where it can get especially complex. It's easy enough to stand up a VM in the cloud. I mean, anyone can do that. It's no different from doing it on your ground hardware. But the point of getting access to that data and plumbing your network and your virtual machines out of your ground and into a cloud network can be challenging. And the common answer of using a VPN, while it certainly may work, it presents its own set of challenges in that they can be complex, finicky. IPsec VPNs can be less than reliable and require a lot of babysitting. Not to mention there's challenges just in how do you extend your network to the cloud without creating a whole DR network or having to re-IP your ground network in order to get access to the cloud resources. There's not an easy product that I can just install and it's going to solve that network problem for me. It's not going to re-engineer and build all those paths out. So you have to sit down and think about, okay, how do I get access to my data? What do I have today in my network infrastructure that can support a VPN tunnel or that can build a connection to my cloud resources? And on the other side of that, whereas you can log in to your firewall, you've got granular control and visibility to the rules, you know what you're running. On the other end of that VPN tunnel, at the end of the day, it's their hardware, it's Amazon's, and you can manipulate firewall rules and you can control what's going on, but there may even be some specific guidelines around NTUs or, it has to be 1404 bytes or something unique like that. The moral of the story there being that VPNs are difficult to manage, and it's not an ideal way to provide access. And remember, we wanted to do all this to make our lives easier, just like we wanted to virtualize to make our lives easier, but we haven't really solved that complexity issue of getting all of the orchestration. How do we solve the cost issues, and how do we make those really interoperable? I don't want to have a homogeneous environment that's all shoved into the cloud. I need to have something on premises, or vice versa. And that's where we start to run into the barriers of actually deploying it. It's not hard to provide a reliable internet connection, but it can be hard to provide a redundant one. How do you connect those ground and cloud resources seamlessly so that the end users don't know what's going on, and that it's also a manageable network diagram, a networking paradigm that you can actually understand, that you can maintain, and that you can document and keep up with as it's going to change. And also, yeah, making sure that if you've got production workloads in the cloud, the speed of your pipe and how you get connectivity to the cloud is really imperative, so that you've got a very similar experience for your users, whether they're using ground workloads or cloud workloads. You don't want to have to call and tell, someone's calling in and complaining about performance. You don't want to have to say, okay, well, you're running on a cloud workload, so you're going to have an extra 10 to 15 milliseconds latency. You just have to expect that to be slow. That's not an answer we can give to anyone, right? Reliably, and then in the hybrid environment, that's where it can really get challenging. And cloud provider, their support for what you run in the cloud or what you run on the ground for your networking equipment is somewhat limited. And the configurations that they require, again, I was talking about the special NTUs, things like that, they generally deviate from traditional point-to-point models that we're used to. And that makes it far more complex to integrate into your existing network infrastructure, not to mention as you grow or as you need to change or even shift your workloads or shift how your business is using the cloud, it makes scaling those resources challenging and difficult. And that's probably the biggest barrier is, it's not how to create resources, it's not how do I get access or how do I run workloads in the cloud, how do I get to them? Beyond that, the management overhead of having multiple tools, of having to log into a cloud interface, and then having to log into your vSphere, HC3, whatever your ground resource interfaces are, making sure that you've got security and compliance that are going to meet the needs of whatever you have, and that your ground and your cloud resources have the same level of compliance and that they're going to pass an audit, along with licensing and optimization. Are you licensed to run in cloud? Do they have a different licensing model for that? And then how do you keep the resource sprawl down? It's a lot like the user model of if you give them any storage, they're going to consume everything you get. So no matter how big your quota is for email or your home drive, they will use it up. And in organizations where you're giving people access to cloud resources, the same thing happens. It's the exact same, I'm just going to try this, set this VM up, I'm going to give it a shot. And the pet project winds up sitting up there as an instance that's always on and that's consuming resources, and you tend to forget about it. So it's really important to make sure that you're keeping your resources and what you're consuming, keeping those in check. So you don't wind up with a $30,000 bill at the end of the month that you certainly weren't expecting. And again, that's going to deviate from the goal of moving to the cloud was to have some predictable monthly costs. And then are my costs matching up with what my utilization should be? Am I oversubscribed or undersubscribed on resources? And do I need to add more? If I'm adding resources on my ground infrastructure or my ground cluster, do I have to have additional resources added to my cloud resources? Are those going to scale well in parallel? And then if I wanted to go the service route, as easy as it is and as wonderful as it is to be able to offshore and break apart all of those individual services that can be delivered, and the list is really too long to note here, the cost for paying for those services certainly outweighs the cost of having, set up your own and created your own, manage your own version manage your own DHCP, manage your own AD. And it's orders of magnitude more expensive, but at the end of the day, you're paying to not have to worry about managing those, right? And that's kind of like what we think about cloud resources. You're paying a premium to not have to manage the underlying hardware. Because I don't care what the host is, I don't care what the storage is. All I want is to have a VM with 4 CPUs, 16 gigs of memory, and 200 gigs of persistent disks, and 100 gig of SSD. I don't care where those are coming from. That's just what I want my guests to see. And that experience and that level of simplicity is one of the things that we deliver with HC3 is that cloud-like experience of having a one-click deployment where on a cluster I want to set up a VM. I don't care what drive it's coming from, where it's going to be allocated. I just want to create a VM that's going to have reliable storage, it's going to have these resources I defined, and away it goes. And that's really what we want out of that cloud-like experience, is not having to worry about what's underneath of that. So now everyone wants to have a hybrid cloud, because we all know why it's a bad idea to maybe push all of our workloads to the cloud, but we also want to gain some diversification and have mixed resources. Well, the definition of a hybrid cloud is also one that you're going to have many different answers, but it really is a combination of public and private services, and maybe one or more of which is going to be cloud-based. And to me, the simplest example of this would be if you're running a scale cluster on the ground and you're using Office 365. That is a cloud-delivered service. You're not managing licenses and keys for Office. You're not managing seats or cows for Exchange. You're not managing Exchange. You're just paying a monthly fee for your user, and Microsoft handles the rest. And that is a great example of how the cloud did make our lives easier. But that would still be a hybrid cloud example. You have a combination of services, some of which you are delivering, some of which you are getting from the cloud. And your private cloud really is your on-premises network. And that's really what you should think of it as. That's your cloud, you're managing the resources, but it's a private domain. And that's what HC3 essentially is a private cloud. So how do you build an ideal hybrid cloud? If I need to have more than just occasional services, if I want to actually start having a true hybrid cloud infrastructure set up, how do I actually do that? How do I get started? Well, for the last year, we've been working with Google to try and solve some of those challenges and really make the hybrid cloud model and being able to deploy cloud workloads in combination with HC3 as simple as just using our product is. Talked about having the overhead of different management consoles. One of the principal beauties of HC3 is that you're going to have one console and one interface to manage all of your VMs. And that interface and the day-to-day utilization of using HC3 is just like using a cloud provider. Again, you're creating a virtual machine and you're giving it resources, and that's the extent of the management you have. You manage the VMs and you manage the guest OSs, but the hardware and everything that's presented to the VM you don't care about. And that's really what HC3 is about. It's quick to deploy, very scalable, and it's very fault tolerant and highly available. So it is a cloud in a box that you have on your premises. Google Cloud Platform and their compute engine, obviously they've got a pay-as-you-go and it's a consumable model. They've got flexibility in the resources, so you can create unique size compute instances that are going to match your need. And they're also easy to manage and highly available. For us, Google provides guarantees on the hardware availability, and we don't have to worry about creating another virtual cluster with the overhead of RAID or providing other redundancy, because the cloud providers give us that redundancy. That's the guarantee they give us. So as essential consumers, it's easier for us to stand on top of that. And obviously, Google has been building a huge worldwide infrastructure, not just for their app suite and their core search engine, but really to build an enormous global cloud presence for compute infrastructure. part of the reason they came to us and we wanted to partner with them was that we're both using KVM, so there is similarity in the hypervisor, and they were also very intrigued by the way we handle storage. So there was a lot of, words overused and I hate it, but there were a lot of synergies that existed there. So we were working with them, and Google, along with Amazon and Azure, their biggest, I guess, feature add to their platform was the support of nested virtualization. So nested virtualization really is allowing us to create virtual scale nodes on Google's platform. So as a compute instance, instead of loading up and standing up a Windows host or a Linux box, we are actually running virtual scale nodes on Google's hardware. We don't have to worry about what's underneath. We're just creating nodes. And then you run virtual machines, and you create, and you have your own virtual scale node just as if it were a virtual single node. The only difference is it's managed and it's run in the cloud on Google. The other part of, how do I get access to that and solving that is integrating the networking into Cloud Unity allows us to simplify and make it really fairly turnkey to say, okay, here's how I can get access to my VMs. Here's how I can extend my ground network. I'm not going to have to go out and buy 6 figures worth of networking gear and or consulting time to figure out how to engineer my IP network to get access to my services. It's built into the product. And that's really how it should be, right? Because what's the point of having this huge and this great cloud platform if you can't get access to your resources there on a consistent basis? So Google Cloud, again, it's KVM based just like us. Like any cloud offering, they're very flexible in their configurations. And Google Compute Engine is basically running HC3 on top of that. So we create a virtual HC3 single node, much like you have a standard scale single node, which you could deploy. The difference is you're going to have a virtual node running on cloud hardware, and you've also got a lot of flexibility and elasticity in how you want to configure that, which is nice because without dealing with a specific set of hardware from vendors, we can create some configurations that maybe match your needs where I need to have 50 plus terabytes of storage, but I'm really only going to need to back up or protect 5 or 6 VMs. That's possible now with Cloud Unity, whereas before, to create a matching disaster recovery cluster with, equivalent storage would be a larger investment in hardware than you may have wanted to make. And then also, it's simple to use and consume because it's a monthly model for how you actually consume it. The networking is built in, simple pricing, and then even just like HC3 is, simple setup and configuration. It's not a week-long engagement of how do we get everything set up and connected, how do I build out my network. It's downloading basically a container VM that provides all that bridge networking. Now, Cloud Unity DR is the first, that's the first product that we have available for Cloud Unity, and it is a fully managed, basically a DR as a service offering, and it's an end-to-end service. Networking is built in. We're just creating virtual nodes on Google's cloud, but it's just like as if you had deployed a single node at a data center that you owned or had another spot across town. It's going to be using our native replication. It's just like as if you had bought and stood up your own single node, and it's going to be managed the same way. We also include a DR planning service, which gets you a disaster recovery plan, along with a test that will help you execute to make sure that your DR plan works. And that's all based on a monthly subscription model. The DIY approach, certainly not bad, but this is just one you're going to manage it yourself. You're going to provide and maintain the site-to-site networking between your data centers or your office and your DR site. and replicating that and protecting that to a single node or remote cluster, and it's all with physical hardware. And then you've got to build out your own DR plan and strategy. Again, going with the X as a service model, anything as a service should be comprehensive, and it should be, we feel it should be white glove so that the end user and whoever is managing is going to have to do as little as possible to get this up and going and off the ground. And if anyone who's gone through the experience of setting up a scale cluster has probably experienced how simple and straightforward that is as well. And pricing availability. So really getting this down to a really affordable, consumable price, starting at really $850 a month, would protect, probably half of the people on this call would be enough to fit into that window. Giving you that DR plan, helping you execute that test, and walking you through that whole process. So as of now, we're waiting on Google to move nested virtualization, which is currently a beta feature, out of beta and into full support. So we're anticipating that to finish up shortly, and then we plan to be launching in next quarter here. So within the next 4 to 8 weeks, probably realistically. But now let's look at something more fun and go to a live demo here. So what you're looking at is a basic 3-node HC3 cluster. I've already got some VMs up and running. To get to the point of actually running a cluster where I can log on, again, this is a web interface where I can log on and upload ISOs. This really takes about an hour or less. I have done a Spiceworks on the air where I did it in less than 30 minutes. But again, it is dead simple to get up and running for your ground cluster on HC3. But on the other end of this, you can see it's still in the same network that I've got. I have a smaller single node running. It has one large disk rather than if you look at your normal physical hardware, you'll see a 4 disks per node, 8 disks per node. We don't have to do multiple disks because the redundancy, again, it's provided underneath to us by Google. So we can just create a large disk in a compute instance, set it up, and then that last mile is the networking component. So what we have is a gateway VM that is small enough really to be a container. It's 1 core and half a gig of memory. And it's really a small CentOS instance that's running Open vSwitch, but all you have to do is power this VM on, and it builds up a connection, establishes a secure tunnel, establishes a VXLAN tunnel up to the Cloud Unity node automatically. So to get set up and get access to the cloud really involves importing this VM and powering it on, giving it the remote IP address of your Cloud Unity node, and then that tunnel is built. From then on, we are just going to be setting up replication I'm going to replicate that VM and protect it here. I'm not configuring a VPN. I'm not working with a telco provider. I'm not trying to get an MPLS link or anything in. I'm literally using one VM, and the core requirements are that it have outbound internet access. It will build up the secure tunnel without having to punch holes through your firewall. And it also does all the magic of extending your ground network to the cloud. So what if I need to get access to the data and I can't get a scale cluster to run my Unity Gateway VM on? Well, this is a fairly stock VM, and there's nothing terribly proprietary about it. So you can export this and run this on an ESX host, VirtualBox just running inside of your laptop. It's not a proprietary HC3 VM. So if you were at a remote site, you could connect your gateway VM up to, and again, whether that's running on your laptop, running on a Intel NUC, running on an old ESX host, you can get that VM up and running, and as soon as that's powered on and gets access to the internet, it's going to build that tunnel up to the remote cloud Unity node automatically, and from wherever office you powered on that gateway, you're now on your cloud network. So beyond replicating, I can send workloads up there very easily. I can also replicate them back. In most instances, we all know that the true level of a DR, unless you're living in a hurricane-afflicted area, is not necessarily going to be your building burning down or having been destroyed. It's going to be something rather simple. User corruption, I need this file back. Something happened, but it's not a disaster. Again, so on a day-to-day basis, you have access to your remote cloud Unity node, and without having to go through a full disaster declaration, if I just had one or two VMs I wanted to power on and have access to, I could very easily do that, without having to run and engage a whole DR plan. And the part of the way we can keep the cost of the service down for Cloud Unity DR is that during your day-to-day, I'm just replicating my data up to the Cloud Unity node, we don't have to run a huge compute instance. So it's not like running ESX on Amazon where you have to build out these incredibly large compute instances that cost 5 figures a month. We're running replication on a node, on a virtual node that has 2 CPUs and 13 gigs of memory. 13 came from Google. It's one of their pre-built sizes, but it's less money that way. But that's all it takes to run replication. In an actual disaster mode, you're going to need more than 8 gigs of memory and 2 CPUs. What would happen would be we resize those nodes with additional cores and additional memory. So then in a true DR scenario, I can get all my workloads powered on and up and running. But outside of that DR scope, on your day-to-day basis, as long as the VM has 8 gigs or less memory, and you can even change the clone to have less than 8 gigs if you wanted to power on, for your day-to-day restores, this isn't something you're going to have to call in or hit a red button for. You have access to it. And also, if you happen to be more than just you weren't just recovering a file and you were running a workload for any significant period of time, the process of replicating that back really is not challenging either, because we're just going to re-replicate that VM back from the cloud node to the ground node. But as long as that ground cluster was intact and there wasn't any damage to it, we're only going to have to send back the blocks that changed for however long you were running that on the remote node. Now, these are concepts that are similar to our replication, because really outside of the Unity Gateway VM concept, everything else here that we're doing, especially with what you would be using, is just like using native HC3 replication. There's nothing that's going to be out of the ordinary from that standpoint. You don't have to set up an account or deal with Google or worry about logging into their console and managing your resources there. That's all handled by us and by Google through our partnership. We literally get to deliver you a virtual single node. So through the magic of nested virtualization, we've been able to really make some significant leaps and strides into how we can tear down some of the barriers that exist in getting a cloud or a hybrid cloud up and running without the intimidation or the sophistication that can come when you're trying to figure out networking, you're trying to figure out how do I want to manage my workloads, what is it going to take, do I need to go and spend another couple of weeks learning a cloud platform, or is it going to be something where I just have a VM I need to import and I can get access to my remote resources? So with that, I will open the floor to Q&A. See what we've got coming through here. Oh, we've got a ton. Okay. Are there any other cloud providers we're looking to utilize? Yes. So we are, I'll call them the big three, Azure, Google, and Amazon all have support for nested virtualization. Google is still in beta, but that's going to be production soon. Azure has support. They announced that last year. It's expanding to more and more machine types, but the moral of the story is we're looking at both other, potentially other cloud providers, but really we're looking at expanding outside the U.S. to Canada and the U.K. are the next stops for us. How customizable? Okay, you got that. Getting a full recovery environment from a slow cloud link. What can we do to speed up the recovery of VMs and still provide near land speeds? I guess that's going to depend on what your ground to cloud latency is going to look like. In a full environment recovery, so if your ground cluster was offline for some reason, the only recovery time you're going to have is wherever your DR site is or whatever part of your DR plan, power on that gateway VM to get access to the cloud resources, and then you can start cloning and powering on the VMs just as if you would from a standard replication. Offices in Asia. So, like I just mentioned that a minute ago, right now the next steps we're going to are outside of the U.S. are Canada and the U.K. But Google has, they've been adding presence in Asia Pacific, and they've got they're bringing 2 more regions on next year. But as they expand, we'll be looking to see if we can expand into those markets as well. How much control over geolocation? So I guess I'm wondering if geolocation, you can choose which data centers in North America, you can choose where you want to have your instance running. So if you wanted to give yourself diversity of protection, so I'm in California and I want to run in Iowa, you can certainly do that. So you can choose the zone and region for which your cloud instances will be. How much can you compact VMs for backing up from the cloud to a cluster on site? That's a great question. I guess I'll try and answer with what I think you're asking for. So replicating from the cloud to your ground cluster or vice versa, the first time you're bursting all of your data from your ground cluster is going to require a full sync. So you have to send every block that you're going to protect and every VM has to get replicated up there. Now, when you're failing back or replicating back, after you've been running a workload in the cloud for a while, you're only going to have to send back what's changed. Now, there also is a fair amount of, especially if you've been using things like clones and you've got, a master image and you created most of your VMs and they're all descended from 1 or 2 clones, that replication process of coming back is going to be even faster because we'll have, these are the same blocks. We can essentially, it's not dedupe, but we can skip past those because those are our common blocks. Can I run VDI and HC3? The short answer is yes. And I've been, one of our beta customers runs a product called WorkSpot, and we had done a beta test where he was creating and spinning up VDI instances on a Cloud Unity node, and that worked great. and just doing a ping from his ground to cloud latency was about 35 to 40 milliseconds, and the users were okay with that. But that's really that's RDP, so it's not too heavy. Looking at others. How has hybrid cloud changed hyperconverged infrastructure? Well, I think it changed it because it's a hybrid cloud is trying to match the simplicity of HCI, really. But it's forced us to look at really why is the cloud not the optimal place for all of our workloads, but how do we add diversification? And that to me is that's my 2018 is the year of I don't want to say the hybrid cloud, but the year of the diverse workload, where it's becoming tangible and it's getting within our grasp to easily have a set of workloads that run in your ground environment on premises and a set of workloads that run in a cloud environment. Regardless of what those are for and how you break those apart and how those are determined, I think that's the point where we're finally reaching that threshold of where that's affordable and that's easy enough to do without having to be a Fortune 50 enterprise. Different themes for the interface? Not right now. They're still going to be the same. Well, if there's no more questions, I am a green guy on Scale at Spiceworks. You can feel free to shoot me a DM. Otherwise, I'm also just Mike at scalecomputing.com. I've got an easy enough email to remember, so if you have a question that didn't get answered today or you can't hit me up on Spiceworks, feel free to drop me an email.
Okay, well, thanks, Mike, and appreciate everyone's participation in the questions and submitting those in. If any of those did not get answered, remember, we'll have a chance to follow up after today and get you that information. And just a couple of reminders before we close up. We have a link in the resources section, so take a look at that for some more information. If you stepped away or missed any part of today's presentation, you will receive a link to view this recording on demand, so you'll get that in a couple of days. So special thanks for Scale Computing for creating the content and sponsoring this event. We thank all of you for tuning in today, and we'll see you next time for another Spiceworks Partner Webinar. Take care, everyone.